Hello, and welcome back to the Raw Code Academy. I'm your host, David Flanagan. Today, I want to introduce you to a relatively recent open source project that is going to change the way you handle your Kubernetes networking policies and more. That project is called Otterize. It's got a complete evolution on the way that we configure networking access within our clusters, using something called IBAC, Intent-Based Access Control. And we're going to dive into what that means in just a moment. Now, like I said, Authorize is different. It isn't a service mesh. It doesn't change your pods, injecting proxies and sidecars in order to control your traffic. Instead, it integrates with Kubernetes, Kafka, Istio, configuring the tools that you're already using in your cluster, but providing a better DX to allow you to do that as a dev team. To understand more, let's dive into what IBAC actually means. So here we have the Authorize website. You can find this at authorize.com, and the page we're looking at right now is the IBAC page, /IBAC. Now, intent-based access control is a declarative way that allows you to define which services are allowed to call other services within your cluster. Traditionally, the way that this would be handled, or at least what I've seen from working with many organizations, is that the developers don't focus at all on security or policy. Especially in a microservice environment, where teams are responsible for one or more services, they really only throw together enough YAML for a deployment and a service within a cluster. All of the security and policy happens from some sort of SRE, DevOps, or platform team, or if your organization is lucky enough to have one, a security team. Now, this means that we have a violation of the law of Demeter. The law of Demeter really just means that we don't want leaky extractions. We don't really want our security platform DevOps teams to have to understand the entirety of a microservice architecture to be able to put together these security policies, because inevitably they're going to get it wrong, or it's just going to be a lot harder than it should be. And if we're going to provide a declarative way to define all of this access, why not allow the developers to do it? Picture this. You're working on a service. You write the code that makes a network call. It wants to speak to Kafka, consume a topic, publish to a topic, or perhaps even make a gRPC or HTTP request to another service. You wrote the code. You know what the intent is. You intend for your service to communicate or speak to another service. So why not log those intents inside of your repository right next to your service? And that's what IBAC wants to change. Using something called the intents file, which is really just a Kubernetes resource, a custom resource, you can say that my service, using this example here, the checkout service, calls these other services. Now, where this extends beyond what we're familiar with traditional Kubernetes networking policies, is that there's some L7 awareness baked into what Authorize can do. So you can see here that we define that HTTP requests are allowed on this path with these methods. Taking this even further to something you can't do with network policies in Kubernetes is here we have a Kafka intent, which allows us to produce messages, write messages on a topic called orders. This is very fine-grained ACL that needs to be configured on the Kafka broker itself. And Authorize can make that happen. So that's enough chat. Let's get hands-on. In this demo, we're going to install Authorize. I'm going to show you how to add enough intents for Authorize to create Kubernetes networking policies for you. Authorize allows you to ease in to using Authorize, and we'll take a look at how we can run Authorize in shadow mode and enforcement mode, before finally taking a look at Authorized Cloud, which will allow us to visualize and build a map topology of all of the services and their access permissions within our cluster. Let's dive right in. Okay, so let's install Authorize into our cluster. Here we have the Authorized organization on GitHub with a repository called Helm charts, which, you guessed it, has their Helm charts. Right now, we're going to focus on Authorize Kubernetes. This will actually install all the other charts into your cluster, giving you a complete authorized deployment. Just to cover what these other charts are, the intents operator is what takes your intents custom resource and creates policies and ACLs with other software running in your cluster. The network mapper just maps the services within your cluster to understand the way that traffic flows and allows you to generate a diagram to visualize that. So the first thing we need to do is add the Helm repository. Like so. Next, we can install Otterize. Easiest thing I've done all day. Let's just give that 2 moments. And done. Now we can run kube control authorized system get pods. And we'll see each of those components spinning up. Let's crack on. Okay, so let's take a look at what's running inside of our cluster. Here we have the Weaveworks Sock Shop demo. This is a sample store built with multiple microservices and a whole bunch of services that allow them to communicate with one another. We also have the front end exposed on a load balancer service, meaning we can browse it. We can view products and view the cart. If we click login, we get a dialog, and if we click register, we get a dialog. If we open login again, we can type user and password. And login successful. So let's use an authorized intents file to make the communication between these services more explicit. Okay, so let's first of all log out. Then we'll jump back to VS Code where we have an empty intents.yaml. I'm going to paste in an example resource that works for this demo. Here we define an authorized client intents with whatever name you wish. Of course, if it makes sense, bonus points. We then define a spec where we say that we want to specify the intents for the front-end service. The front-end service being the application that runs in our browser, the web app, which is likely going to call pretty much every service. But right now, we're only going to make explicit that it calls the user service. So we can come to the CLI and apply our intents.yaml. And what's going to happen now is that the intents operator is going to detect a custom resource and create a network policy. We can describe that network policy, and we will see that it specifies a pod selector where the server is user sockshop E8BOA2. It then has an allow ingress from a pod selector where there is a label which allows access to user sockshop EBBOA2 true. Now the intents operator behind the scenes is resolving the service names in our client intents and allocating the labels to facilitate the traffic. If we jump back to the web browser and hit refresh, saying we wish to log in, it works. Now, of course, all we've done is allow traffic. We haven't blocked any traffic. So let's head back over to our intents.yaml, where we can add a protected service. Here, we're going to say that the user service is protected, which means all traffic that doesn't have an intent will be blocked. We can now come back over here and apply our updated intents.yaml and run netpol again. We'll now see that 3 seconds ago, a default deny user network policy which does not allow any ingress, targets our user service. We can now come back over to the sock shop, where we can ask it to log in. Success. So let's make one more change. We're now going to update our front-end intents, and instead of the user service, we'll say that it's allowed to communicate with the order service. Our network policies will now be updated. We now have access to orders from SockShop and still our default deny on a user service. Meaning, we come back to log in for the third time. No success. That's because our browser is now unable to communicate with the user service, to the point where we've crashed the Weaveworks SockShop demo. So let's come back and add another service for our front end to speak to, the user service. We can now do kube control apply, intents, get netpol, and try to log in again. Success. So let's protect one more service. We'll copy our protect service and paste. This time, we're going to protect the catalog service. Now, no client intents specify that they call this service, meaning we will get a new default deny network policy for the catalog service. So let's come back here and refresh the sock shop. And as you can see, most of the services are working, including log in and log out. However, there are no products available on the homepage. And that's how intent files and protected services work with Authorize. This two-phase approach to defining how your services communicate means that you can adopt Authorize step by step. You can add all of your client intents without ever breaking any traffic within your cluster. As you have comfort that your intents cover most of your traffic, or all of your traffic ideally, you can begin to protect your services one by one. Now, there is a better way to do this, using Authorized Cloud. Let's take a look. Authorized Cloud is a SaaS product with a very generous free tier that should satisfy most of you watching this video. The benefits of using the cloud are that Authorize provides visual understanding of your intents and the enforcement. So let's log in. The first thing we need to do is connect our cluster. We can give this a name, like so. And we'll call this environment production. This gives you the Helm commands that you need to run to connect to Authorized Cloud. I'm saying no to Authorize already be installed on my cluster because I did a Helm delete prior to this step. But if you do have it installed, it's fine. Authorized Cloud is just a value add-on. We also get to decide whether we wish to be in enforcement mode or shadow. We're going to leave enforcement mode off. This means we'll be using the protected service custom resource that you've seen a moment ago. Of course, if you wish to delete enforcement mode, the protected services will not be required. Let's copy the Helm install command. Like so. We can now see that our network mapper, the intents operator, and the credentials operator will begin to stay connected. Some may take longer than the rest. If we pop over to the CLI, we can run get pods. When all of these are running, we will have a visual topology map of all the services running in our cluster. Let's come back in a moment. So here is the access graph. This shows us the services within our cluster and the communication patterns, as well as whether the access would be allowed or denied. We can see the front end wants to speak to orders and user. User is protected and the traffic is allowed. Whereas our front end, currently traffic is allowed, but that's because the service is unprotected. Now this only shows the services that have client intents, but there is a network mapper feature of Authorize. So let's go browse around the website just to give it a little traffic to analyze. And then jump back to our access graph. And already we can see services popping up within our cluster. So let's filter on our sock shop namespace. And we can see now that our front end speaks to carts, user, orders, catalog, session DB. Our queue master speaks to Rabbit, and our catalog speaks to the database. The orders has its own database, the user has a database, and the carts has a database. We can now see all of the traffic scanned by Authorize. So we can see at the moment our front end is not allowed to speak to catalog because we protected the service without an intent. And that our catalog currently can speak to its database, however, is because it's an unprotected service. So let's change that. Let's add that our front end speaks to the catalog. And also allow our catalog to speak to the catalog DB, like so. Now the catalog is the only service that speaks to the catalog DB, so we're going to protect that too. Like so. Now, we can do kube control apply, intents. And if we come back to our access graph in real time, it's going to reload and show us the changes through our intents and our protected services. We can now see that our front end speaks to the catalog and is protected, and the catalog speaks to the catalog DB and it's also protected. The ideal situation. But what about the rest of our services? So here we are in the command line again. And you'll be pleased to know that Authorize have a CLI. This CLI allows you to work with the network mapper, where you can list all the services and the communication. You can even visualize setting an output path, like so. We can now open our PNG and get a visualization of everything without Authorized Cloud. But I think we can all agree the cloud's a bit nicer. So let's run network map export, which dumps out all of the YAML that you need to map your intents. and overwrite our intents.yaml. We can now apply this directly to our cluster. And we can ignore the intents that already exist. Let's come back to our access graph, which will reload in real time. Now all the warnings disappear, and we can protect the services that we wish to protect. And that is pretty cool. So I hope you have enjoyed what you've seen. Authorize is pretty sweet. It's an open source project that allows your developers to write client intents next to the code itself. Services can be protected or enforced by default. You can use the network mapper to scan your cluster as it is right now and export a huge amount of YAML into your repository. You can visualize it with the CLI or hook into Authorized Cloud for that nicer experience. So go check it out. Until next time, have a great day.